Hi everybody, today I want to solve a slightly more difficult problem on dynamics and conservation laws. It is also very important to practice your skill of using different reference frames in this problem and a center of mass frame in particular. So let's dive into the problem. A dumbbell consisting of two identical balls connected by a weightless rod of length L stands vertically on a perfectly smooth horizontal surface. The lower ball is instantaneously given a horizontal speed VO. For what values of VO will the ball slide without lifting off the surface? What will be the speed of the upper ball at the moment it strikes the horizontal surface? In the picture number 1, you can see the initial position of the dumbbell, and it is much easier to answer all the questions in the problem if the motion of the dumbbell is considered in the reference frame where its center of mass moves vertically. Clearly, this reference frame moves relative to the laboratory frame with a constant horizontal velocity, a half of VO, and is also inertial. It's very important. In this frame, the velocity of the balls at the initial moment are VO divided by 2 and are directed horizontally in opposite directions. You can see the situation in this reference frame in the picture number 2. So let us determine under what condition the lower ball would lift off the surface. It is clear that in this case, the normal reaction force of the surface is 0, and therefore the dumbbell falls with the acceleration of gravity, g. Since the dumbbell also rotates around its center of mass, the lower ball has a centripetal acceleration, let's call it AN, associated with this rotation, and is directed upward. As we know the formula for centripetal acceleration, we can write that AN is the half of VO squared divided by the half of L. And therefore, AN is VO squared divided by 2L. The ball will lift off if AN is greater than G, obviously. And otherwise, the ball will remain in contact with the surface. And for this, the speed must satisfy the condition of VO squared being less than 2GL. To find the speed of the upper ball at the moment of impact, we can use the law of conservation of energy. At that moment, in this new reference frame, its speed, let it be V1, is directed vertically downward, and the speed of the sliding ball on the surface becomes 0. You can see it in the picture number 3. In this frame, the center of mass falls vertically. At the moment the dumbbell strikes the surface, the rod that connects the balls is horizontal, so the horizontal components of the velocities of all its points, including the midpoint and ends, are 0 at the moment of impact. Thus, the law of conservation of energy in this introduced reference frame that is connected to the center of mass can be written as mv1 squared divided by 2 is equal to mgl plus 2 times m half of v0 squared divided by 2. From this equation, we get that v1 squared is equal to 2gl plus VO squared divided by 2. In the laboratory reference frame, the speed v of the falling ball at the moment of impact is given by v squared equals v1 squared plus the half of vo squared, which means that v squared is equal to 2gl plus 3/4 vo squared. That's it for the problem. Thank you so much for watching, and if you want to suggest some more problems or more topics to be discovered in my videos, please let me know. Thank you.